Okay, find an equation for the tangent line. Always remember that for the tangent, for any line, to write an equation for any line, you need a point, say x1, y1, and the slope, which we denote usually by m. If it is tangent line, then this guy will be a point on the graph of the function, a point or a point on the graph, which in this case, our graph is a curve in the plane, and the point is given. This is 0, 1 over 2. Well, actually, you can check that this is a point on the on the graph of the equation. Why? Because if I plug in x equal to 0 and y equal to half, I get sine inverse of 0 plus sine inverse of 1 over 2. This would, sine inverse of 0 is 0. What is the angle whose sine is 1 over 2? That's sine inverse of 1 over 2. Well, you have to be careful. You should put an angle which is in the interval negative pi over 2 and pi over 2, and that is pi over 6. And as you can see, it satisfies the equation. Okay, that's just a checking thing. But the second thing that we look for in the tangent line case is the slope, and we always find the derivative of the function at that point. Let's say this. Or if this is the case, so if the equation or the function is something implicitly defined, then what you basically find dy dx, but when x is that x1 and y is that y1. It means that you have to differentiate and plug in those values. For us, that x1 and y1 we already know are 0 and 1 over 2. Okay, we have to find derivative. When I look at the equation, it's not the regular explicit differentiation. This is where implicit differentiation comes in. And always implicit differentiation it starts with differentiating two sides of the equation. So d dx with respect to x of sine inverse x plus sine inverse y and d dx of pi over 6. Using the sum rule and derivative of sine inverse, you get 1 over root 1 minus x squared for the first one. For the second one, this will happen always in the implicit differentiation. When you differentiate a term which has y prime, you have to apply chain rule version of that differentiation rule. So here, sine inverse of y, we are differentiating with respect to x. It will be y prime over root 1 minus y squared. And the right-hand side, derivative of pi over 6. It's constant. Doesn't matter what is that constant. The derivative of constant is always 0. Now we have to find y prime. Well, you can either do the find y prime itself and then plug in, or plug in x and y, and then solve for y prime and then plug in for x and y. So here I will do the second method. So I first find for y prime, and then set x equal to 0 and y equal to 1 over 2. And that will give me minus root 1 minus half squared 1 minus 0 squared. Denominator is root 1. Root 1 is 1, so I don't need to be worried about that part. And this is 1 minus 1 over 4, which is negative 3 over root 3 over 4, which is the same thing as negative 3 over 2. We found the slope. Let me just write it now back here. and we have the point. What you do the next step, write the equation y minus y1 equals to m times x minus x1. Y minus y1 is 1 over 2, m is root 3 over 2, x minus 0. So this is y equals to negative root 3 over 2x plus 1 over 2. And that is the equation for the tangent line to the graph of the curve given by that